Okay, I'm recording the lecture for January 30th, section 5-5, roots of real numbers. So far we have the radical sign, and the thing underneath of it is called the radicand, the number. Now we have one more piece, and this is called the index. So in Nemeth code, that comes before the open radical sign, and this number can be, like, when it's a square root, it's a 2. So that's called the index. And that tells you what root you're taking. So we could have something like fourth root of 81. So you'd have your radical sign, and if it's print, it's just a little tiny 4 by the left side of your radical sign. And in Nemeth, it comes before the radical sign. It's a number. So that's all the pieces of the square root. Now, the first thing I really want to talk about is, let's look at a square root. Okay, so let's say square root of 16. Who knows what the square root of 16 is?
4.
4, right, because it's 4 squared. So if you look at it, square root and a square are inverse operations. So I'm going to abbreviate square root as SQRT, and then just square as an SQ. So these are inverse operations, kind of like addition is the inverse of subtraction, that kind of stuff. It's undoing the one or the other. So what other number can be a square root of 16? So we've said the square root of 16 is 4. Is there another number that will work for that?
-4.
Thank you. Yes, -4. Because you can have 4 or -4. Why does -4 work? Correct. A negative times a negative is a positive. So we have, sorry, Andrew, I'm going to invite you. This is right over the top of my thing. That's right. Okay, Elliot is here, so he's playing with his school bus right now, so that's what the laughing is. Okay. All right. Let me. Okay. Okay, there we go.
That sounds really surreal.
I know, doesn't it? Whoa. Okay, so we have two roots, so the square root of 16 equals plus or minus 4. Agreed? Yes. So now we have something called the principal root. The principal root. And that is with a, let's see here, that's with a PAL. So principal root is the positive, the non-negative root. So that's the non-negative root. So in this instance, which one is our principal root? 4, right. So 4 equals the principal root, which I just abbreviated as PR. All right. So, yeah, you guys have seen this before, right? Okay. And one thing I just want to quickly just go over. Now, if you have something like a cubed equals 125, this a, basically we're looking at the base a and asking ourselves what number raised to the third power equals 125. So what times what times what equals 125? What's 5 times 5? Well, it's 25 times 5. 125. So 5 cubed is 125. So our root is the 5, and we cube it. So basically we're saying 5, we can say this as 5 is the cube root of 125. So 5 is the cube root of 125. Just like we can say 4 is the square root of 16. Does that make sense?
Yep.
Okay. Now we can write this in a generic form. When we write this as a raised to the n, as in Nancy, a raised to the n equals b, where n are the factors of a. So that's like a times a times a times a dot 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 times a, and that would equal b, where b is the number that we're taking the square root of. So we say a is the nth, it's hard to say, a is the nth root of b. Oh yeah, I see you want to play dominoes? Okay, you can play with those. So that makes sense to everybody, yeah?
Yep.
Okay. All right. So I just want to make sure we understand that. Now, let's talk more about some principle kind of stuff. So I'm going to get us a new whiteboard. Oh, would you like me to open it? Okay. There you go. He wants to play dominoes. Who wants to play dominoes with him? I think it would be a fun game. It would be quite interesting. Okay, so we said the square root of 16 equals 4, and that's our PR, our principal root. Now, if we have negative square root of 16, so what this is saying is negative 16 is the opposite of the principal square root of 16. So basically what that means is you take the square root and you take the principal one and then you multiply it by a negative. So if our principal root is 4, then this would be negative 4. Okay? All right. So now, if you have a plus or minus in front of the square root of 16, this means we want both roots. This means we want both plus and minus 4. All right. Now, here's one. So what if we have the third root of negative 125? Now, this is different. When you have a negative index number, it's actually legal to do this. Because what is negative 5 times negative 5 times negative 5?
That would be negative 125.
Right, negative 125. So you can do that. So when you have cube root of negative 125, that would actually equal negative 5. That is the cube root of it, not a positive. This one is a negative because we want negative 5 times negative 5 times negative 5. Whereas if they were all positives, we get a positive 125. He's okay. So, and then the last one we have is the fourth or negative fourth root of 81 equals negative 3. So what this is saying, because the negative's on the outside, indicates the opposite of the principal fourth root of 81. So basically it's saying -3 times -3 times -3 times -3. And you can do this because, oh, sorry, we're doing the opposite of the principal root. So it's +3 times +3 times +3 times +3, and then you slap your negative on afterwards. Because 3 to the 4th power is 81. There's a great table on page 246 that shows the real nth roots of b. So if you want to take a look at that, so you have even and odd. So if you have even roots, okay, so I'm going to get myself another new whiteboard. Maybe. Oh, yeah, here we are. Okay, so let's look at this really quickly. Now let's look at our n, if our n value or our index number is even. So our n or our index number so if b, which remember is the number underneath, so I'm going to write this up here. So we have our radicand. Our general form is b is our radicand, n is our index number. So if our b term underneath, our b term being radicand, if our b is greater than 1, meaning anything, or sorry, greater than 0, anything positive, anything underneath the radical is positive, then we get one positive root and one negative root. So if we have, I'm going to write this, if we have our b term, our b is greater than 0, we're going to end up with one positive root and one negative root. I mean, that's just like something like we did, square root of 25. Our index number is actually a 2, so it's an even index number. So we get positive and negative 5. Now, if we have an even index number, where we have b is less than 0, there is no roots. There are no answers possible if we have a negative number under the radical sign with an even index. So there's no roots. Let me give you an example. That'd be like the square root of -16. You can't get that, right? Okay, and now the last one, what if n equals 0? So we have, oh, sorry, b equals 0, not n. I was writing n. So b equals 0. So that would be like the square root of 0. Our answer is always going to be exactly that, 0. Okay, so those are the even ones. Now I'm going to zip up on the whiteboard all the way to the top, and now let's talk about the odd index numbers. Odd index numbers. I apologize for the writing, it's kind of a lag. Okay, so now again, if we have an odd index number and with b under as our radicand and b is greater than 0, we are going to have again one positive and one negative root. I will be posting this recording up on Yammer as well. So here's an example. Okay. So this is with b greater than 0. So what if we have the third root of 8? So that's with b greater than 0. So now if we have, again, index number of n, radicand of b, where b is less than 0, we're going to have no positive, we have 0 positive roots, and we have one negative root. So this is an example of, we have the 5th root of negative 32. And the root is actually 2, because negative 2 times negative 2 times negative 2 times negative 2 times negative 2 gives us negative 32. But there's no way to get a positive, so our root is actually negative 2. All right, I'm sliding over to the section 3 on the whiteboard. Okay, so let's look at an example. So we need to simplify this. So we're doing plus and minus the square root of 25x to the 4th. So we have an even, oh my goodness,